today we discuss 12th class chemistry. Okay, and this new series will discuss over all the unit, okay, that is present over your NCERT book. Okay, one by one I'll complete all the unit. So this will be your chemistry part 2, 12th class chemistry part 2, and in that first unit we are discussing that we call haloalkane and haloarenes. Okay, so haloalkanes and haloarenes. We are discussing today haloalkane and haloarenes. In this lecture series, you will get your like entire concept. You will get clear all the NCERT problem we are going to solve over here, and then you will get 100% concept of entire 12th class. Okay, so watch this, and whatever you are finding doubt that you may ask me in a comment section so I can answer your doubts also. Okay, so haloalkane and haloarenes. When we are starting for haloalkanes, we know that haloalkanes is something that is connected, the halogen is directly connected with the sp3 carbon, correct? This X is, suppose this X is halogen and it is directly connected to sp3 carbon, so this carbon is sp3, correct? Likewise for haloarenes, we know that this will be directly connected to your sp2 carbon. This is halogen that is directly connected to your carbon, which carbon is having sp2 hybridization, correct? We can say in this the more polar due to less percentage S character, right? In this case we can say this is more polar in comparison with these haloarenes. Okay, if you are comparing with haloarenes, this will be more polar, so more polar due to less percentage S character. Okay, here the percentage S character is less. How the percentage S character is less? For sp3, what is the percentage S character? Only 25%. Okay, percentage S character. You see 25% S and 75% P is there, right? But here in this case, so it will be less polar. Okay, less polar due to more percentage S character. Okay, S character comparison to or compared to haloalkane. Okay, haloalkane. Correct. Here, what is the percentage as character? It is 33.3%. So how the polarity depends on percentage as character? See, suppose here percentage as character is 25, and you know that the more the percentage as character, it will behave like a more electronegative, right? If suppose percentage as character is less over here, what will happen? This carbon will have less pooling effect of this bonded pair of electrons. So what will happen? This halogen will pull entire, like all the electron pair, it will pull towards itself. Let me change the color and then I'll explain you. See here both the electron towards this halogen, correct? Because here the percentage as character is less, so it is not having that effect. Okay, that pulling effect it won't have. But in this case, see here also it is halogen, here also it is halogen, correct? Now what is happening? The bonded pair of electron here it is toward your halogen, but here little bit far from your halogen. Okay, it will be towards carbon side, not entirely towards carbon side, because if we compare the electronegativity between this carbon and this halogen, we know that this halogen is having more electronegative. Okay, but still now this carbon is sp2, so for this carbon we have the percentage as character is 33.3%. If we have 33.3% and that is more as character than compared to your sp3 hybrid carbon, where the percentage as character is only 25%, correct? So here it is what is happening. If percentage as character is more, the paired bonded pair of electron it will pull little bit toward itself, so the polarity will decrease, correct? Here the polarity will be more because we can directly give this symbol, like the positivity will be over this carbon and entire electron density will move towards this halogen. But in this case what will happen, we can't say that entirely polarity will be moved towards one side. Okay, so somewhere we will give this positivity, like the shifting of positivity, correct? So it means this is less polar, and this will be this is more polar, and this will be less polar. Okay, due to this percentage as character. Here the percentage as character is more, here it is less. Correct. Now, actually, this is only introduction part we are doing for haloalkanes and haloarenes. As I told you, that entire syllabus I'll complete one unit, like one by one. All the unit I'll cover up for the 12th standard chemistry. Similarly, I'll start for 11th also. So this is a request from a student that first you complete 12th standard, because you will have examination on February, right? So before that, I want to complete entire chemistry. So this class I am taking in Dumka. That is Dumka is a district headquarter, and it is situated in Jharkhand. Okay, well-known place. So now the first point we can write in introduction for haloalkanes and haloarenes. The first point, like we can say that generally. Okay, you can note down all these notes also, because I'm going to give you all the notes also, like how you are going to write in your academic examination, as well as the concept I'll give you that will help you for your NEET examination and JEE Main examination and JEE Advanced. Correct. So generally used as, so how, where the haloalkanes and haloarenes are used. So for that we will write generally used as organic. Okay, organic solvent. Generally used as organic solvent. Okay, why? Because it is relatively it is non-polar. Okay, relatively non-polar. So that's why for solvent purpose it is using in a very various industries, or maybe paint they are using. Okay, for painting purpose, for dilution of paint they are using this organic solvent. Correct. Then it is also used in, we can write, it is used in medicinal industry. Okay, how? So as antibiotic, you know that antibiotic is also used. Okay, the various antibiotics are there where the halogens are the active element. So the name, we can say that for typhoid we are using chloramphenicol. Okay, here chlorine is used. Okay, likewise it is help to maintain, okay, help to maintain thyroxine. It's a kind of hormone. Okay, thyroxine hormone. Okay, and what is the required element for this? Iodine. Okay, iodine is regulating this thyroxine hormone, and if iodine deficiency is there, you will face that thyroxine is behaving like irregular form, and then you will get the disease called goiter. Okay, correct. Now next is your, like, for anesthetic purpose also we are using. Okay, so that is like halothane. Halothane is used as an anesthetic, okay, during surgery. One more they were using, that chloroform, but now they have banned that one. Okay, chloroform is also well-known anesthetic. In movies also you have seen that they are putting in the handkerchief and then they are putting in mouth, and the person is getting anesthetic, and then they are taking away. Okay, so that is already banned over here. Then one more is that anti-malaria, we know that is chloroquine is used for the treatment of malaria. So these notes also you can write it down. It will very much helping in your academic examination. Okay, the 12th standard examination you are going to appear, or maybe the sessional test, or midterm test, it will be there. So for that it will be helping out. Okay, now we'll directly, this is introduction part is over. Okay, this we have discussed only the introduction part. Okay, introduction of haloalkanes and haloarenes. Now directly we'll go for classification. Correct. So next will be your classification. Classification. So in classification, there are the bases. Okay, so now this classification is on the basis of, Okay, on the basis of number of halogen, correct? So suppose only one halogen is there, so we'll say mono halogen, or sorry, not mono halogen, mono halo alkane. Suppose two halogen are there, we say that dihaloalkane, correct? Likewise, in that aromatic ring, if one halogen is there, we can say mono haloarenes. If more than one halogen is there, suppose two halogens are there, we say that dihaloarenes. Okay, monohaloarenes, dihaloarenes. So now, see, there are many. Okay, we are not going to write that in three halogen we will attach and then we can say that trihaloalkane. So that we are not going to do it. That much smart you are, you can do that. So directly we will go with the monohaloalkanes. So the monohaloalkanes again we can classify how one will be like based on sp3 carbon connected to your halogen, and another one is your sp2 carbon is connected with your halogen. Okay, this monohaloalkane, I'm talking about this monohaloalkane. So this can be further classified based on this attachment of your halogen compound. If it is attaching to the carbon which is sp3, and again the second type is if your carbon is attaching with sp2. Okay, your halogen is attaching the carbon which is sp2 hybridization. So this way also we can classify it. So this again we can further classify. Okay, further classification is like first one we will call it haloalkanes. Second we can call it allylic halides, and third will be your benzylic halides. Okay, haloalkanes means we know that primary, secondary, tertiary. Allylic halides we know, benzylic halides also we'll see. So all the, like, whether it's a allylic halides or benzylic halides or haloalkanes, like all the places the halogen is directly attached to the carbon which is sp3 hybrid carbon. Okay, now for this sp2 hybrid carbon where the halogen is attached, the first one is like your vinylic halides. Okay, and then your aryl halide. Okay, these are the two types where the sp2 carbon is present, and remaining these are the sp3. Okay, so few students or some students get confused with the allylic halides, how it is like it is connected to sp3, but today you will going to see with the benzylic and allylic it is connected to the sp3 hybrid carbons. Remaining, whoever know that for them it is uh, okay, fine, they can do revision with this class, and who doesn't know they will get a new concept with that. Okay, so first one by one I'll discuss all the things, this all the three and these two, five. The five thing we will discuss. First we'll take up the haloalkanes. Okay, so first one is haloalkane, correct? So haloalkanes, we know that the molecular general formula, what is the molecular general formula for this? Molecular general formula, okay, represented by how it is CnH2n, okay, then plus 1 and then X. Okay, X can be anything, fluorine, chlorine, bromine, iodine. Okay, or we can say that these are, okay, this is second point, this is first point, this is second point. These are further classified, okay, classified as primary, secondary and tertiary, okay, according to the nature of carbon, okay, to which halogen is attached. Why I'm writing all these things? Because there are many students who doesn't have uh, money to expend for the coaching. Okay, wasteless coaching. So better you appear over here in a free, because I know everyone is having mobile phone and they have data in their mobile. So please utilize it and write these notes. It is very beneficial for your 12th standard. Okay, you are appearing for 12th standard now. February month the board examination will be there. So maybe many students has completed their syllabus. Okay, and many are have still not started. So this is your starting point. Every day I'll give you and I'll complete your 12th standard syllabus, and then 11th also I'll complete it. Okay, so please do write the notes also, that will be helpful for you. Okay, got it? The halogen is attached. Then the next point will be, if halogen, okay, is attached, if halogen is attached to a primary carbon, to a primary carbon atom in an alkyl halide. Okay, so what we call it is primary alkyl halide. Okay, or we can say directly 1 degree alkyl halide. Correct? Similarly, we can say, okay, similarly, secondary and tertiary alkyl, or we can say attached with, maybe with this, similarly secondary and tertiary carbon atom, okay, is attached with, okay, secondary and tertiary carbon atom respectively. It means, if suppose your alkyl halide is attached with your secondary carbon and tertiary carbon, we call it secondary alkyl halide, tertiary alkyl halide respectively. That the meaning. Okay, so suppose we'll see the example, because that also you have to write to gain more marks. So you just write it, hydrogen, hydrogen, here X, and this side you put R. So this is your primary. Okay, this we call it primary. Why it is primary? Because see, the halogen is attached to this carbon, and this carbon is attached only with single carbon. Okay, so single carbon means it is primary, or we can write it like primary. Okay, now what is secondary? So this one is R and this one is R double prime, and here hydrogen and this X. This we call secondary. Okay, or 2 degree. Correct? Like, because this halogen is attached to this carbon and this carbon is attached with the nearby 2 carbon or 2 alkyl group. So we call it secondary. What is the tertiary? This is double prime, this is single prime, and this is triple prime. And here the halogen. So see, this halogen is attached with the carbon, and this carbon is again further attached with the 3 alkyl group. So 3 alkyl group means this is tertiary. Correct? And we call it 3 degree. Got it? Now this is your haloalkanes completed. Next we are taking, see, haloalkanes completed, will take mark. Next will be your allylic halides. Correct? So next one will be your allylic halides. Correct. This is your allylic halide. So to find allylic halide, it is very easy. Okay, so first we will write the definition. Okay, and what is allylic halide? First we will write it and then we see the example. So we can say that these are the compound, these are the compounds in which the halogen atom, okay, the halogen atom is bonded to an sp3 hybridized, this is very important, okay, sp3 hybridized carbon atom. This one is very important. If you are attaching with the sp2, then this allylic will change to vinylic also. Okay, So be careful about that. If you are attaching with sp3, then it is allylic, and if you are attaching with sp2, then it will be called the vinylic. Okay. So hybridized carbon atom adjacent to, and this is also very much important, adjacent to carbon carbon double bond. Okay, carbon carbon double bond, that should be maintained. Okay, so we call it, like we can say, known as allylic carbon. So how we will see? See, this is CH2, this is CH, and here one CH3 is there, right? Okay, or halide you have told, so we will put halide group over here, CH2, and here X halide group. So this position we call it allylic position. Okay, see, this is allylic position. See, this is sp2, this is also sp2, and next to this sp2 we have this carbon which is sp3. So if this carbon is sp3, and here next to this double bond, the first carbon whatever it is coming and it is sp3, then we call it, it's a allylic position, and whatever is attached to the allylic position, that name it will come. Like here the halogen is attached, so this name will be allylic halide. So this condition you should know, that next to the double bond, that carbon should be sp3 hybridized, so that position we call it allylic. Likewise, okay, in a cyclic form, if double bond is there, so there are two allylic position. Okay, there are two allylic position. See, this is sp2, okay, sp2, and this one is your sp3, right? sp3. Here also one sp3 is there, right? So this position is your allylic. Here this position is your allylic. See, next to sp2, like this double bond, next to double bond, the carbon it will come where the sp3 hybridized carbon is present. We call it, this is allylic position. Now suppose you are adding here halogen, so it will be allylic halide. Okay, this will be your allylic halide. You can attach halogen over here also. If you are attaching over here also, it is also called the allylic halide only. Correct. But the thing is, it should be sp3 and it should be next to the double bond, right? So likewise, for benzylic also we will write it. Okay, benzylic halide. Okay, benzylic halide, we can write it first. These are the compounds in which the halogen, okay, the halogen atom is bonded to an sp3 hybridized carbon atom. Okay, sp3 hybridized carbon atom. Okay, so what is that? These are the compound in which the halogen atom is bonded to an sp3 hybridized carbon atom. Okay, hybridized carbon atom attached to, and it is further attached to an aromatic. Okay, this is important over here, so it will be benzylic, otherwise it will be again allylic only, right? Aromatic ring. So we known as, so it known as benzylic carbon, correct? So how this will look? See, this is aromatic. Here you put one methyl. So this name we know already, right? This we call toluene. If here it is CH3, then this name is toluene. Now we know that, I'll change the color. See, in this case, this is sp2 and this carbon is your sp3. So this position we call it benzylic position because it is directly attached to the aromatic ring. So this we call it benzylic. So the question might be asked, like, in toluene whether benzylic position is there or not. So in toluene benzylic position is there. Okay. Now if in this benzylic position if you are attaching, so I'll use the same color to draw here CH2 and then you are attaching your halogen. So now what is happening? See here this will be your benzylic position. Okay, and this compound is known as benzylic halide. So here the aromatic ring, but the halogen is attached to the haloalkane only, means alkane only. sp3, sp3 means alkane, sp2 means alkene, sp means alkyne, correct? So it is attached with the alkane, so it will come under haloalkane only, correct? So these are the three we have completed, these three haloalkanes, allylic halide and benzylic halide. Okay, so wait for the next class, we will complete these two, vinylic halides and aryl halides will complete, and then directly we'll go for the nomenclature, and then we'll go for preparation, after preparation physical properties, after physical properties chemical reactions. Okay, we'll see. So we will, like this we will complete, and one folder I will make over here, and with that folder I'll write it this 12th class NCERT based chemistry. You go with that playlist, you will find all your classes. Okay, so it is starting today only, and going forward you will find it. And if you need, if you want to interact more with the questions, or maybe you are having some query, so what we will do, slowly we will come live, and the live interaction we will do it, and that is upon request. If you're requesting, then only I'll come live and I'll discuss it. Otherwise, if suppose I came to live and you are only one or two students, how could I discuss, right? So if viewer are more, if you're subscribing more, so what I'll do, I'll come live, and whatever doubt you are having, the by the time, like immediately I will solve those doubt, and then I'll move forward, correct? So that will be better, right? I like seeing recording, and if you are in live, so live will be more beneficial than your recording classes, correct? So for today this much only. So next class, wait for next class. In the next class we will see the vinylic, okay, and your aryl halide, correct? So thank you very much for watching.